Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules.
Welcome to Lesson 3, Copy and Bisect an Angle. Bisect means to cut it in half so that each half is equal. Alright, so classwork, opening exercise. In the following figure, circles have been constructed so that the endpoints of the diameter of each circle coincide with the endpoints of each segment of the equilateral triangle. Okay, so what they're saying is if I just focus on this circle, circle E, its diameter is AC. Circle F's diameter is AB, and circle D's diameter is CB. So these three diameters form an equilateral triangle. Okay, so it says, what is special about point D, E, and F? Explain how this can be confirmed with the use of a compass. Okay, so if we think about this, if a circle's diameter, if AC is a diameter of the circle and E is the center of the circle, then AE is a radius and EC is a radius, and 2 radii equals a diameter. Radius are half the diameter, so therefore those are midpoints. Okay, so D, E, and F are midpoints. The compass can be adjusted to the length of CE and used to compare the lengths of AE, AF, PF, CD, and BD. So let me do that. Okay, so it says if we adjust the length of CE, so if I put the compass point on C and I rotate the compass and open up, I missed again. And there we go. Bring that down so it's on the line. Okay, so if I put the compass on there and draw a little mark, oops, what's going on here? Draw a little mark, hey, try that again. There we go, that moved, undo. All right, draw a little mark, and if I go over to D, it's right there. Bring the point over to B, rotate it around so it's not making a mark, and make a mark, and look at that, it went right through F. And then if I put it on A and rotated it around, it would end up on F as well. I don't have my compass open quite as far as I should, but you get the idea. Okay, with electronics you can't get it perfect. All right, so anywho, there it is. Okay. Part B says to draw line segment DE. So let me get a ruler. Okay, so DE, so if I put my ruler end 0 on E and put that there, and then if I draw a line segment DE, as they told us to do, and then EF, so just rotate this over to here and draw a line segment from E to F, and then finally FD, so put this at 0 there, rotate it to D, and draw a segment. Okay, so draw DE, EF, and FD. What kind of triangle must DEF be? What kind of triangle would that be? Well, it is also an equilateral triangle. So you'd say triangle DEF is an equilateral triangle. How do we know that? If we took our compass and put it on D, well, we've already done that. DF is a radius, FE is a radius, ED is a radius of the three circles that are congruent. So all the radii are congruent, therefore all the sides are congruent, therefore it is an equilateral triangle. C says, what is special about the four triangles within triangle A, B, C. Now there are 4 triangles here. There's triangle CDE, there's triangle DEF, there's triangle BDF, and there's triangle AEF. What is special about those 4 triangles? All 4 triangles are equilateral triangles of equal side lengths. They are all congruent because they are all radii. CE is a radius of circle E. EA is a radius of circle E. AF is a radius of circle F, and it's congruent. They're all congruent. D says, how many times greater is the area of triangle ABC, triangle ABC, the big triangle, than the area of triangle CDE? So, okay, so I made that triangle. Whoops. I made that triangle, and it's right here. It is triangle CDE right here. And if you look, it's 1, 2, 3, and then if I rotate it, 4 times. So the big triangle has 4 of this size triangles in it, so it is 4 times greater than the little triangle. The area of triangle ABC is 4 times greater than the area of triangle CDE. Okay, page 2 brings us to a discussion. We're going to define the terms angle, interior of an angle, and angle bisector. So we're going to start with the definition of an angle. An angle is, what is an angle? So I'm going to go click on this. I'm going to explain it to you with a picture before I just give you the definition. So if I draw a ray, let's make it blue. There's a ray. Okay, no angle, just a simple ray. And by definition, a ray is a set of all points on a straight line that has one starting point, but no end point. So it starts here, and there's just a bunch of infinite number of points going in the same direction, forming a straight line, if you will, but it has one end point. So a ray, you have a starting point but no finish, and it just goes forever and ever. Okay, so then I'm going to switch colors. I'm going to draw another ray, but this one's going to be red. And I'm going to start at the same exact point, but I'm going to go off in another direction. That is 2 rays starting at the same point, forming an angle. So let me bring in the definition. Okay, so it is the union of 2 non-collinear rays with the same endpoint. So here are 2 rays with the same endpoint, and they're not on the same line. What would a collinear look like? That right there. So it would be 2 rays just sitting on top of each other with an angle of 0, but we would never say that because we don't see both rays. We would just say, oh, that's a ray, because you wouldn't be able to see both of them. Okay, so anyhow, there is an angle. 2 non-collinear rays with the same endpoint. Interior. The interior of angle BAC is a set of points in the intersection of the half plane of AC that contains B and the half plane of AB that contains C. Okay, so those are rays, by the way. So let me just switch to my pen. So that's ray AB, I believe. Or is it line AB? No, it's line AB. The interior of angle BAC is the set of points in the intersection of the half plane of AC that contains B and the half plane of AB that contains C. The interior is easy to identify because it is always the smaller region of the 2 regions defined by the angle, the region that is convex. The other region is called the exterior of the angle. Okay, so what they're saying is, if you had a line, so let me draw this. This is stubborn. Okay, so I'm going to draw a line now. So a line goes forever in both directions. Okay, so I've constructed this diagram, so let me explain interior of an angle. I drew a line, the red line, see there's arrows at both ends, that is a line that goes on forever and ever, and there's a point A and a point B on it, so I can call that line AB. Okay. So that is right here. Line AB that contains C, so a half plane. Okay, so the line's red, so the half plane is the pink. That is the plane on the top, up above of this line segment. So keep in mind a plane is a flat surface that goes in all directions forever. But this is a half plane, so anything above this red line is half of the plane. Anything below would be the other half, and I don't have that shaded. So this pink area here, including this green, this pink here is the half plane that contains C, and that is right here. Line AB that contains C, the half plane of line AB that contains C, and it also has the half plane of AC. So here's line AC right here, okay, that contains, actually I don't need this D down here, it's irrelevant. So now I have a line with A and C on it, that's the green line, and the half plane that contains B. So AC is right here, this green line. The B is on the half plane in the green, and this green would continue forever this way as well. So we want points that are in both the pink and the green section, which is anywhere in here. So my angle is angle CAB. CAB is right here. My angle is anything in here. So that is the interior of this angle right here. Anything outside is the exterior. Anything out here is the exterior. Okay. Okay, now we're on to angle bisector. It says if C, a point C, is in the interior of angle AOB. So now that we know what an interior is, if I have an angle like so, I'm just going to draw this quickly to save time. And this is, okay, my pen's not working properly. Okay, so if this point here is A, and this point here is O, and then this point here is B. That is angle AOB. When we say angle AOC, oh, I'm sorry, if C is in the interior of angle AOB, so then I've got a C in here, and that is C. So it's in the interior, and bisect means to cut it into two congruent pieces. So then that would mean if I drew another ray from O through C, then my two angles I just formed, this one and this one, are congruent. So then we'd say, if C is in the interior of angle AOB, and the measure of AOC, measure of angle AOC equals the measure of angle COB, which I've marked with one arc, then ray OC bisects angle AOB, and ray OC is called the bisector of angle AOB. When we say the measure of angle AOC equals the measure of angle COB, we mean that the angle measures are equal. So if, let's say, angle AOC is 20 degrees, that would mean angle COB is 20 degrees. I'm sorry, angle AOC is 20 degrees and angle COB is 20 degrees, and the whole thing, angle AOB, is the sum of those two, or 40 degrees. When we say angle AOC, okay, we mean the measures are equal. There it is right there again. Okay. Geometry assumption. In working with lines and angles, we again make specific assumptions that need to be identified. For example, in the definition of interior of an angle above, we assume that an angle separated the plane into two disjoint sets. This follows from the assumption, given a line, the points of the plane that do not lie on the line form two sets called half planes, such that 1, each of the sets is convex, okay, and 2, if P is a point in one of the sets and Q is a point in the other, then the segment PQ intersects the line. So that means we have a plane. We have a plane, and this piece of paper is a plane, and we draw a line, okay, like so. And if we put the point here and a point here, and we call one P, and we call the other Q, then the line segment PQ intersects the line. Okay, that's all that was saying. From this assumption, another obvious fact follows about a segment that intersects the sides of an angle. If given angle AOB, like right here, then for any point C in the interior of angle AOB, the ray OC always intersects the segment AB. Okay, so that means that if I drew a line segment now from A to B, then my ray that bisects the angle is going to intersect that segment. It's going to cross it, and it did. Okay, here's page 3, and it says, in this lesson, we move from working with line segments to working with angles, specifically with bisecting angles. Before we do this, we need to clarify our assumptions about measuring angles. These assumptions are based upon what we know about a protractor that measures up to 180-degree angles. 1. To every angle AOB, there corresponds a quantity measure of angle AOB called the degree of measure of the angle, so that the measure of angle AOB is between 0 and 180 degrees. So it's more than 0 degrees, but less than 180. This number, of course, can be thought of as the angle measurement in degrees of the interior part of the angle, which is what we read off of a protractor when measuring an angle. In particular, we have also seen that we can use protractors to add angles. Number 2, if C is a point in the interior of angle AOB, then the measure of angle AOC plus the measure of angle COB equals the measure of angle AOB, which I stated on the last page. Two angles, angle BAC and angle CAD, form a linear pair if AB and AD rays, ray AB and ray AD are opposite rays on a line, and AC, ray AC, is any other ray in earlier grades. We abbreviated this situation and the fact that the measures of the angles on the line add up to 180 degrees as angles on a line. Now we state it formally as one of our assumptions. 3. If two angles, angle BAC and angle CAD, form a linear pair. Now let me just show you an example of that. So if I have angle BAC, okay, remember an angle is formed by two rays. So I will choose my ray segment, and I'll choose this, and how about red? And I draw this ray like so. And I'm going to name that endpoint B. Where am I? If two angles, BAC, actually, I don't want B there, I want A there. So this is ray AB. So there's ray AB, and then I draw another ray. How about orange? From A over here, doesn't matter what the measure is, and then I put points on that, and this is a C. Okay, so I have ray AB, I have ray AC. So if two angles, BAC and angle CAD, so here's C, here's A already, form a linear pair. Okay, so now my points are in the wrong place, so let me just switch them. No, actually I can do something, let me see. If two angles, BAC and CAD, oh, okay. So then I can put another ray, AD, like so. Okay, let me just get rid of this. Rewrite that A so it's not in the way. And put a point out here called D. Okay, so I have ray AB, I have ray AC forming angle BAC. I also have a ray AD that goes the opposite direction as AB, and that is forming angle CAD. So angle BAC plus angle CAD form this straight line DB. That is a linear pair. Two angles that add up to 180 degrees. So if two angles, BAC and CAD, form a linear pair, then they are supplementary. The measures of angle BAC plus the measure of angle CAD equal 180. So if this was 40 degrees, then this would have to be 140 degrees, totaling 180. Protractors also help us to draw angles of specified measures. So let OB be a ray on the edge of a half plane H. For every R, such that R is between 0 and 180, there's exactly one ray, OA, with A in H, such that the measure of angle AOB equals R degrees. So let me talk about that one now. Let's get rid of all this. Okay, so I'm going to show my process of doing this time. So I'm just going to choose a color, red's fine, and I'm going to draw OB. So I'm going to draw ray OB. Okay, so OB, here's O, here's B. Let OB be a ray on the edge of the half plane H. Okay, so actually my half plane would stop at this point here because ray, so let me just move that. So here we go. There we go. So that would be the plane, half plane, formed by ray OB. Remember, this would go on forever this way only. Okay, so let OB be a ray on the edge of the half plane H. So let me label that H, so H is out here. This is the half plane H. Okay. For every R, such that R is between 0 and 180, there's exactly one ray, OA, with A in H, such that the measure of angle AOB equals R degrees. So what they mean is there is exactly one ray, OA. So if R is, pick a degree, doesn't matter to me, if R is 70 degrees, that means that there is only one R, where the measure of angle AOB is R degrees. So there is only one A in H. So if this is 90, 70 would be here. So if I draw a ray, like so, let OB, here's ray OB, here's B, no, that's OB, I'm sorry. Let OB be a ray on the edge of the half plane H for every R such that R is between 0 and 180, 70 degrees. So if this is R, angle R, that's 70 degrees. There is exactly one ray, OA, with A in H, such that the measure of angle AOB equals that R degrees, which we chose to be 70 for this example. Okay, that makes sense? That is the only point in this side of the ray OB plane that would make a 70-degree angle. If I moved it over here, that wouldn't, it'd be 70, but there's no ray over here. And so therefore that is the, and actually this plane would continue this way because it said R is between 0 and 180. So I could be over here, but I'd still be on H. So that is the only change I would have to make, is bringing this over like so. But if I pop my angle over here, that would be more than 90. It goes all the way up to 180. So there's only one point in the plane that would create a ray, that would create an angle where R is 70 degrees. Okay, now mathematical modeling exercise 1. It says, investigate how to bisect an angle. You need a compass and a straight edge. Okay, there's my straight edge, and there's my compass, and they're way up at the top here. So I bring these down, and bring that back up. Okay, so there's my compass, there's my straight edge. Joey and his brother Jimmy are working on making a picture frame as a birthday gift for their mother. Although they have the wooden pieces for the frame, they need to find the angle bisector to accurately fit the edges of the pieces together. Using your compass and straight edge, show how the boys bisect the corner angles of the wood piece below to create the finished frame on the right. Okay, so what you would do is you would take your compass and you would put it right there on the corner of the piece of wood, and you would bring this out like so, rotate it, okay, just moved a little, right there, make an arc right here, that would go through, actually let me move it over here a little. We want to create an arc that goes through this side, and then rotate it around over here, create an arc through this. So what I've done is, hopefully you can see this okay, I have made an arc of the same distance on each ray. Then I'm going to take, and I'll change colors now, and put my compass point on the arc intersection of that ray and create a mark here on the interior of this angle. And then I would come over and do the same over here, put this right on there, rotate it around, and draw an arc here. So what I have just done is created basically a circle, and then the same distance from the edge of that circle in two places, which is here. And then I would take my straight edge, put it at the corner where I want to start the cut, rotate until I go through the intersection of that arc I just created, and draw a line segment through there. And that would make the angle bisector. Okay, so I brought in the steps. 1, label the vertex of angle as A. So now I'm going to follow these steps and show you what I did. Label the vertex A, that's this point right here. Draw circle A, centered at A, any size radius. Okay, that was the blue I did. I didn't do an entire circle, but if I did, it would have created these arcs here. I've just done this enough times where I know that that circle would intersect both rays. Okay, label the intersections of circle A with rays of angles as B and C. So this would be B right here, and this point over here would be C. Draw circle B. Draw circle B, centered at B. So I put my compass here, and then this would be the circle B right here, this arc. And then draw circle C right here, centered at C, with the same radius as B. So circle B and circle C have the same radius. At least one of the two intersection points of circle B and circle C lie in the angle. Label that intersection point D. So that's my arc. That is my arc intersection. and that is right here, and then I drew ray AD. Okay, page 4 brings us to these three angles where they want us to consider how the use of circles aids the construction of an angle bisector. Be sure to label the construction as it progresses and to include the labels in your steps. Experiment with the angles below to determine the correct steps for the construction. So I'm going to give the steps again. Okay, so these are the steps I gave on the prior page. Now we're just going to follow them. So I get my compass and I get my straight edge. Okay, and then we get to work. All right, so I'm going to take my compass, label vertex of angle A. Label the vertex of the angle as A. So I put a dot right here and call it A. That's the vertex. Draw a circle A centered at A, any size radius. So then I put this at A, like so, and open the compass to any radius. I'll go to here, and it says draw a circle. So I'm going to do the whole circle this time. So there it is. Okay, let me get rid of this mark. So there's step 1 and 2. Step 3 says label the intersections of circle A with the rays of the angle as B and C. So then I go and I put a point right here, call it B, and put a point right here and call it C. That is number 3. Number 4 says to draw circle B centered at B, radius BC. So you center your compass, which means put the point on B, change the color, rotate it around. Okay. So obviously you're going to use a compass on paper. It's a little bit different process here, and then we want to draw a radius of C. So I just move this out so I'm on C, draw a circle. I'm doing an entire circle this time. So there's the circle centered at B with a radius of C. So if I drew a segment here, it would be BC. That would be the radius of the circle B. And then draw circle C, centered C, radius CB. Well, if I put my circle, my compass here and draw a circle, I'm going to go through B because BC and CB are the same thing. See that? BC radius, CB radius. It's the same segment, same radius, so it's a circle with the same radius. So don't move your compass, don't adjust your compass when you're moving from centering at B to centering at C. So now I've drawn 2 circles, and it created 2 intersections. So at least one of the 2 intersection points of circle B and circle C lie in the angle. Well, at least one, at most one, because this is not in the angle in this case. I guess if you, I don't know, if you made a bigger angle or smaller angle, there's always going to be one outside. So I don't want this point intersection here, but I could use it. So if I did use this point here and this point here and draw a ray AD, so they're not saying to draw a line, so I won't use that other point. It says now draw ray AD. All right, notice how I'm trying to be really precise here. And then I draw ray going through, and there is my point D. All right, so there's my construction. There's my angle bisector. So now angle BAD is congruent to the measure of angle CAD. And I'm going to write that. The measure of angle BAD equals the measure of angle CAD. And then I'm going to just delete my circles so you can see that these 2 angles are congruent. is congruent to that. And I could check that, and I will this time, but only this time. I could bring in my protractor and rotate it around and put my protractor crosshairs right on A like so, and then measure that angle. Oh, my thing's over here. This is my angle measurement thing. Okay. So I bring this down and put it right there, and I roll this over to here, and that is right there. Set that as precisely as possible on that crosshair right there, and that is going right through 45 degrees. So this is a 90-degree angle. As you can see, it's pointing at 90 right here. So half of 90 is 45, so this side's 45 and that side's 45. So there's, using my protractor, I actually found the measures of the two angles, and they are both 45 degrees. Okay, so I'm not going to measure them again, you get the idea. So I'm going to repeat the steps again, or actually, if you what you should do at this point is pause the video, see if you can follow that, and repeat. So here we go. Okay, so here we go on this next one. Label the vertex angle A. So here's A. Draw a circle A, any radius. So I put this right there and draw a circle. That's supposed to be red. Any circle. There it is, red. All right, then I'll switch to blue, and then you put your compass on your intersection point like so, and draw a circle, and then put your compass on the intersection of your red circle, that was the original, and draw a circle. Okay, and now you take your ruler, place it at the vertex A, going through like so, and there's my new ray, and I haven't labeled the angles yet. So I label intersection of circle A with ray angles B and C. So this point right here would have been my B, this point here would have been my C, and this point here is my D. So then I erase the circles. And I have ray AD bisecting angle BAC. So now I would say again, the measure of angle BAD is congruent to the measure of angle DAC. Okay, hopefully you're getting the hang of this. I will do it one more time. Okay, step one, label the vertex A. There's A, right here. Draw a circle centered at A, so circle A, any radius, so I'll just leave it. There's my circle. Then you move your, actually let's label these now. Then you label the intersections B and C. Okay, so here's B and here's C, where the circles intersect the rays. Then I'm going to put the compass right on B, rotate this around, open it up, and it doesn't matter what angle I use or radius I use. I'll just put it here, draw a circle. It's got to be greater than A though. It has to be longer than AB. If it's too short, they will not intersect. And then I put this point on C. So it says draw circle B centered at B, radius BC. Oops, it does matter. I'm not following my directions, I'm thinking of something else. So yes, I put the point on B. I extend this out to C, and I draw a circle. And then I move my center over to C, and I draw a circle. Move my compass out of the way, and I draw a segment from A to the intersection of those two circles I just created, forming a ray. Like so. And I'm going to call this point D. Erase, erase, oops. Struggling here. Where's my delete button? There. And here, and move that out of the way. So now ray AD bisects the angle BAC. So then I'd again say the measure of angle BAD is congruent to the measure of angle CAD. Okay, so if this was 80 degrees, then this is 80 degrees. If this was 30 degrees, this is 30 degrees. Alrighty. Okay, page 5 brings us to mathematical modeling exercise 2, investigate how to copy an angle. Okay, so right there, we are not bisecting anymore. This is something new. We're copying an angle. So you will need a compass and a straight edge. Compass, straight edge. So if you were in class, it'd be you and your partner will be provided with a list of steps. So down here, I have a list of steps. In random order, I mixed them up. All right, they are needed to copy an angle using a compass and a straight edge. Your task is to place the steps in the correct order, then follow the steps to copy the angle below. Okay, so I look at this first thing. Draw circle B centered at B. I don't have any points. I can't do that. Draw circle E centered at E. No points. Label intersections of the circle. There is no circle. Label the vertex of the original angle as B. Well, I can do that, so let's do that. So I'm going to put this here. But before I do, I'm going to read them all. Draw circle F centered at F. Can't. Draw ray EG. There is no letters. Label intersections of circle. Can't. Draw ED. No letters. Label intersections of circle E. There are no letters, so this is the only thing I can do. Label the vertex of the original angle as B. So there's a vertex here. I'm going to call it B. Okay, so now I have to do something. I can't draw a circle. Well, I could draw circle B any radius. I could do that. So that's one thing I can do. Draw circle E, no. Label intersection, there is no circle B yet. Draw circle F, there's no F yet. Draw EG, there's no E or G. Label intersections in circle E, there is no circle E. Draw ED, can't. Label intersection of circle E, I can't. Okay, well, I can do this. So these are the two things I can do. I can draw a ray, call it EG. That's pretty easy. So let's do that. Okay, so I'm going to do this one first. So I'm going to draw a ray. I'll make it green. Let's see, a ray. Make it green. And I'm going to start it here. And I'll just go out like so and have it be horizontal. Okay, so if you were to do this with paper, obviously I've got a program that draws it. You would take your straight edge, put it on your paper, put a dot, and draw a line segment, or a ray, I should say, going one way, and put an arrow on the end. All right, I did it using technology. So there's my ray, and it's called EG. E is my starting point, G is somewhere else on the ray. So here's E, and then G is somewhere else. So I drew EG. All right, so I've labeled the original angle. I've drawn a ray. Now what else can I do? Well, the only other check mark I had was this one. So I am going to draw circle B, center B, any radius. So I'm going to bring my compass over here, put it right at the vertex, open it up any radius. It doesn't matter as long as you're going through the rays. Don't go way out here so you're beyond the rays. And I'm drawing the circle. Okay, so there's my circle. Center B, any radius. That was easy. Draw circle E, center E, radius BA. Well, I don't have a radius BA yet, so I can't do that. Label intersections of circle B with the sides of the angle as A and C. Okay, I can do that. Oh, so that's a possibility. Draw circle F, center F. There is no F. Label either intersection of circle E and circle F. No, can't do that. Draw ED. I could draw ED now, but I wouldn't guarantee that it'd be the same angle measure as this, so I can't do that yet. And intersection of circle E, there is no circle E, so this is the only thing I can do now. So label intersections of circle B with sides of the angle as A and C. So that means put a dot here, call that A. Put a dot here, call that C. Done. Okay, now it says draw circle E, center E, radius BA. So in other words, I want to draw a circle radius BA. In other words, copy the circle, so I don't want to move my compass. Bring it over here, centered at E, and draw a circle of radius AB, which is what I just did. So that was draw circle E, radius BA. So there's the circle with the same radius as BA. Follow that? So I have two circles that are congruent. One centered at our original vertex, one centered at the starting point of our new ray. Capiche? All right. So now it says draw circle F. I don't have point F yet. I can't do that. Label either intersection of circle E and circle F. Don't have a circle F. Draw ED. Can't really do that. Label intersection of circle E with EG as F. Okay, I can do that. The intersection of circle E, so I have a circle E intersecting ray EG, so I can call that point right here F. Alrighty? Now it says draw circle F, center F, radius CA. I haven't set my radius up here yet. Label either intersection, draw ED. Okay, so I can do this. So I'm going to draw circle F. This is step 7. So now I'm going to draw circle F, centered at F, with a radius of CA. So to create a radius of CA, I'm going to put my compass point on A or C and put the pencil end of it on the other, in this case C. So it's open too wide here, so I will narrow it up to C. There it is. Let's make this blue. So now I have my compass set. So I'm just going to put a little mark there to show you where this came from, right there. And then I'm going to move this over to F and have my center F. And I'm going to draw a circle, centered F, radius CA. There's my circle with the radius of CA. Label either intersection of circle E and circle F as D. Okay, so label either intersection of circle E and circle F. So here's circle E red, circle F blue. I can label either one of these two intersections, it doesn't matter. I could flip this over and have my angle come down here, or I can go up. I'm going to go up just so it looks the same. So I'm going to label this intersection as D. Okay. So once I've said that, that is the step I can do. And then finally, there's only one step left. Draw ray ED. So I put my ruler on E, rotate it so it's going through D, like so. I want to be really accurate here. Okay, and I'll make this ray green. Like so. Move my ruler out of the way. And this angle, DEF or DEG, whatever you want to call it, is now congruent to angle ABC. Okay? So that's how you copy an angle. Okay, page 5 brings us to relevant vocabulary. Midpoint, degree, zero, and straight angle. I'm not going to read these to you. Pause the video, read the vocabulary, make sure you understand, draw a diagram to try to understand them, and learn the vocabulary. Okay, page 7 brings us to the end of lesson 3. Go to your problem set.